Good morning, everybody. Thanks, everybody, for joining us today for this webinar on accelerating naval design innovation and certification with Siemens Simcenter Simcenter products. My name is Christian de Wet, and I'm the Sales Director at Aerotherm. So this is the agenda for today. So we're going to start off by introducing both Aerotherm and then also Siemens. And Siemens will present the marketing challenges that they experience and how you can use their software to overcome these from an end-to-end process. And then Dimitri will also share some customer success stories. My colleague Jan will then present on STAR-CCM Plus, and then I will present on Amesim, the 1D solution. And then we'll end off today with a few key takeaways and a Q&A session. So people can post their questions in the chat or in the Q&A tab, and then after the webinar, we'll definitely get to answer everybody's question. With that being said, let's jump straight in. There's a lot to cover. Let's start by introducing myself, and then Abdul will present and share the Siemens, what they do. As a brief history about Aerotherm, we are a Siemens expert partner, specifically in STAR-CCM Plus, with more than 30 years of experience. Our slogan is using simulation tools to find cost-effective and practical engineering solutions, and really drive this home with the way that we see and apply CFD in industry. And you can see just the various number of industries that we do cover, and one of them also then being marine. Taking a look at the clients that use the software, this is not a list of the commercial clients. You'll definitely recognize some of these logos on the screen. And then also some of them has either licenses in-house or they make use of us our engineering services division to do consulting work on a per project basis. And we get to the academic aspect. You can see a list of academic clients that currently has active licenses of Simcenter STAR-CCM Plus, with some of these institutions having multiple departments like mechanical, chemical, civil engineering, electrical engineering. So yes, but that's it from our side, and I'm going to ask Abdul to talk about Siemens.
Christian, hello everyone. Good morning. My name is Abdul Ludi. I'm responsible for Simcenter portfolio development across Europe, Middle East, and Africa, and have been with Siemens for almost 27 years. I'd like to take a brief moment to explain who we are as a company. Siemens is a global tech company recognized as the world leader in industrial automation and software. It is also the largest manufacturing company in Europe, with over 300,000 employees supporting our customers across the 5 continents. Last year, Siemens was ranked in the top 10 list of the Time World Best Companies of 2024. Siemens has a rich history. It was founded in 1847 in Berlin, Germany, by a gentleman called Warner von Siemens. Today, the company operates across several strategic sectors like smart infrastructure, energy, mobility, health, and digital industry software, where we are based. Our mission within this division is to help companies drive innovation and enhance competitiveness through digital transformation. And that is everything from design to manufacture and production. Next slide, please. The digital industry division comprised of multiple subdivisions, as you see on the slide. So we have software, factory automation, motion control, manufacturing process-related automation, and finally, our services that offers our customers deep industrial expertise, helping them to bring their product to market faster. The digital software division was established in 2007 with the acquisition of Unigraphics or UGS. Today, it serves as the backbone of our NX shipbuilding design solution. Since then, Siemens has invested over $10 billion in acquiring a number of innovative companies, such as CDWCO, which offers our flagship CFD solution, LMS, Boran, CAD solution, and Mentor Graphics for integrated circuit design, offering all of our key components of Siemens Accelerator, which is a digital platform comprised of integrated end-to-end solution. The Simcenter portfolio is a critical element of Accelerator, which focus on performance prediction, something that we will be looking into more deeply later in the program. Siemens is committed to investing in cutting-edge solutions to keep our customers at the forefront of their industries. In line with this commitment, Siemens recently announced its plan to acquire Alti Engineering. Once completed, this acquisition will position Siemens to offer the world's most comprehensive AI-powered design solutions. With that brief intro, I'm pleased to introduce our next guest, Dr. Dimitri. He's the Siemens Marine Industry Director and brings a wealth of experience, having served as the former Technical Director of the Royal Institute of Naval Architects in the UK. Dimitri, welcome.
Thank you very much. Let me please share my screen. Can you please let me know that you can see my screen?
Yes.
We can see your screen.
Perfect. Thank you.
Yes.
So thank you very much, Abdul, for introduction. Indeed, I've been working in the maritime industry all my life in the various countries and the companies, including Lloyd's Register. I was teaching at university in Norway, and I was technical director at the Royal Institution of Naval Architects. And now I'm responsible on the with the maritime side of Siemens, specifically on the simulation side. So everything is related to simulations, STAR-CCM Plus, Amesim, all other products. So they actually under my radar. So I would like to spend like a few minutes to discuss the key question. So why the maritime industry is actually very important for us as Siemens and what kind of challenges we actually experience in the maritime industry. So as you are aware, in July 2023, International Maritime Organization here in London, so they adopted a new strategy, and according to this strategy, so the entire maritime business, the entire maritime industry should be zero emission by 2050. So strictly speaking, we have only 25 years to achieve this target. So, and as you can imagine, it's actually a very significant technical challenge. So if you think about how many vessels actually sailing now in the planet, so you could be quite surprised that at the moment it's about 100,000 vessels larger than 100 tons. And about like 56, so about 50,000 vessels larger than 1,000 tons. So it means in order to achieve this target, so we need to build quite a lot of retrofit quite a lot of vessels. So it's the scale of about 2,000 to 4,000 vessels a year. And at the moment, so the in the production lines, so we usually build about 1,500 vessels a year. So obviously, retrofitting scale is not significantly larger. So it means, strictly speaking, we're already kind of challenges this time frame, and we need to do the things better in order to address those targets. So from Siemens portfolio, as Abdul correctly pointed out, so we have either acquired or developed quite a lot of tools, and these tools, they actually cover the entire, let's say, life cycle of the ship design. So starting from the very first phase, from the concept design, and then progressing towards the detailed design and also the CTRLs delivering service support and so on. So strictly speaking, this is kind of in the pipeline outline on this side. So you can actually see there are a lot of different designs, a lot of different components. And now with the Siemens solutions, we can actually, I'm sure whether it's not. Yes. So we can actually cover all of these areas. So you can see with the tools developed in-house or acquired with the different companies, so we can actually cover all these kind of points. So it means like Siemens, it's actually in a very good position in the maritime business to provide our client with the full support, starting from the inquiry to the end of the life cycle management. Let me see whether it's, yes, okay. So, and this, how we consider the combination of our tools. So again, it's kind of a similar message. So the flow coming from the requirement, concept, design, and so on, but also in our specific areas. So we're focusing on the simulation part. So it's mainly concept and design, and some other colleagues within Siemens, they might support the further development with the manufacturing and operation. So specifically about the concept and design, so we're talking about the special tool called Simcenter, and this tool is actually helping our clients, to design and build better ships. So in this kind of Simcenter portfolio, so we're specifically talking about the digital simulation, and in here you can see that we can do quite a lot of things related to the structural, fluid, thermal, acoustic, and some other challenges in the maritime industry. The key points of this solution, so why we're a strong partner for industry leader in the maritime business. So because we cover quite a lot of important things. So first of all is we call it model the complexity, and the idea behind that, you can actually use our tools in order to simulate the complex scenarios. So it's not just, let's say, in the hydrodynamics, resistance or propulsion. So you can do the things like landing on helicopter, on the moving decks, and so on. So another important part is actually explore the possibilities. So specifically, if our clients, they want to have the most optimum design, it could be related to the hull form, or could be related to the propeller, or some other components. So you can explore various possibilities within our tools. And actually, the good point of this solution, that you can do it in a relatively short time frame. Another important thing that we paid quite a lot of attention is actually to make our calculation fast. So over the last year, so you see this kind of graph, we managed to reduce the calculation of our solution quite significantly. So just doing optimized algorithm and making sure that, so we calculate exactly what we need to calculate, so without like extra efforts. So we managed to reduce the computational speed, and obviously combining with the previous point of exploring the possibilities, this made kind of, iterations and finding the best possible solutions very important within the limited time frame. And the another point, which is very important, is being connected and stay integrated, because obviously once you develop your hull form, for instance, in CAD software, so and you're happy with the hydrodynamics, it would be very difficult to save this geometry in the like third-party format, and then import this to another software and so on. So by doing so, you can actually lose quite a lot of metadata, and obviously all your efforts you collected before might be lost. So in our solution, because we're covering the entire maritime business, so we can stay actually integrated. So we can show that the things developed in one step, can be easily moved to another step. So keeping all the metadata available. So if you running the hull design or structural design, so you can just easily communicate between these different pieces of software by integrating these tools. So I would also like to share a few customer stories, which, we're very proud of our customers, and we would like to share those stories with you, because it's actually, they had like quite a lot of interesting things. So one story is about Sea Air solution. As you can imagine, this company, so one of their focuses is actually the hydrofoil design. And before, when the hydrofoil was introduced the first time over 100 years ago, it was like a very manual process to design the right shape and angles of hydrofoil, because obviously depending on the shape and the right position and angle, so you either will achieve the right lifting force or not. And can you imagine just optimizing the things manually or physically? So once you have, I don't know, 50, maybe 100 different shapes of hydrofoils, and you're trying to find the best. Can you imagine how much time can you spend in order to find the optimum design? So now with the digital solution, specifically with Simcenter STAR-CCM Plus and X, you can actually run all these optimization processes digitally, numerically. And by doing so, you can find the optimal solution very quickly. So, and you can have a full simulation of this optimal solution. And once you are confident that this solution is the best one, then you can just build this in the actual prototype and see how this hydrofoil, how this vessel behaves in the actual sea. So according to this feedback received from the CER solution, so they managed to reduce the design time by 25%, so which is remarkable case. Another interesting perspective is an example from Robert Allen. So you might be aware, so they're market leaders in terms of the tug designs, tugboats. So they actually had a slightly different challenge. So at the moment is, not apart from building or designing the vessel, you also need to have the class approval from the classification society. And normally it's done, again, so when the vessel is built and, the surveyor from the classification society comes on board, and then they have some sort of test and they just, confirm the acceptance of various criteria. So now with the digital environment, it's actually moved significantly further. So now you can actually simulate these things and get the approval from the classification society based on your simulation rather than the actual sea trials or actual performance at sea. So, and by doing so, obviously, it's a very important step because you can actually get the approval of the design and then build it. So making sure that the final design will be good enough. Because if something is not meeting the criteria of classification society, you still have a chance to redesign this in a digital environment, but it might be too late in the actual environment. So this kind of case is actually very important, showing the development of digital industry, not only from the position of the ship design, but also from the position of classification society. So they all are our clients and we are working very closely with them. And we believe that so this moving of digital class approval is actually one of the interesting steps forward. And the final design or final customer story I would like to share with you is a company called Becker Marine. So they pioneered in terms of the development of energy-saving device. It's called the Möbius duct. So it looks like that. And they make quite significant investigations, and now they sold quite a lot of designs like that. But the key point is they designed this energy-saving device in full scale, so not based on the model test results, from the towing tanks, but actually on the real, one-to-one scale shape. And obviously, by doing so, the simulation or digital environment is the only option. So they fully employ the full-scale simulation, and they optimize the struts, the shapes of the Möbius ducts based on the actual flow around the actual ship. And by doing so, actually, they can optimize this in the best possible way. And you can see, so they might can get some quite a significant savings. So it's $500,000 US annually for the improvement of the flow and reduction of the fuel consumption. So those kind of examples we would like to share with you, but obviously we have many, many more. And if you're interested, so later on we can share you some additional interesting stories. But obviously I'm conscious of the time, so that's how I would like to stop my presentation and give the floor to my colleagues. Thank you very much.
Okay. Good morning, everyone. I am Jan Serfontein, and I'm the Simcenter Technical Specialist at Aerotherm. And in this section, we are going to look at a quick example of a setup to model hull-resistant self-propulsion and complex maneuvering predictions with Simcenter STAR-CCM Plus. So Simcenter STAR-CCM Plus enables its users in the marine section to effortlessly access various elements that contribute to successful simulation in one integrated package. Now, this includes all of those names: fluid dynamics, reacting flow, solid mechanics, and all of those aspects listed. So can simulation provide us with an answer on how our vessel will perform in real life? So we have spent many years building a virtual prototyping environment to do exactly this, help you discover better designs faster with Simcenter STAR-CCM Plus. Now, our tools are built from the ground up for that purpose, and we are helping you innovate better than anyone else. So virtual prototyping gives us a huge advantages over physical prototyping. So no scaling has to be applied, so everything can be done at full scale, and simulation will provide much more insights since you can interrogate your entire simulation domain to better understand the performance of your vessel. Now, in most cases, users rely on multiple tools to complete the entire CFD process. They may need to use different softwares at each stage. Now, if we look at Simcenter STAR-CCM Plus, its key benefit is that everything happens in the same interface and environment from start to finish. Now, this brings significant advantages. It saves time by eliminating the need for file transfers between different tools, reduces training costs as users only need to learn one software, and it improves productivity by keeping the entire workflow within a single platform. And it minimizes errors caused by the file format conversions and software incompatibilities. So the step-by-step CFD process in STAR-CCM Plus is as follows. So firstly is the CAD prep. The first step involves preparing your CAD model, the geometry you receive from any design software, which is then imported into Simcenter STAR-CCM Plus, where it is cleaned up for CFD purposes. Secondly, will be the model setup. The geometric object is converted into a computational model. Now, this involves meshing the geometry and defining necessary physics to simulate the real-world scenario. And then step 3, the simulation execution. Now, once the model is ready and your solver parameters are set, the simulation is launched. And now convergence is monitored through residual plots and tracking of physical quantities. Then step 4 is post-processing. Now, after simulation, results can be analyzed both qualitatively and quantitatively. And then step 4, simulation and post-processing often go hand in hand, particularly for transient simulations. Since these computations can take a very long time, real-time monitoring is very crucial. Now, in conclusion, with STAR-CCM Plus, everything is integrated into a single platform. So the entire CFD process is streamlined with one tool and one interface, making it significantly simpler, faster, and more reliable. So building a virtual prototype is similar to a physical prototype in the sense that you can build your model, in this case a CAD model, and create a mesh around it. You can then test it and assess the results. Now, based on the results, you might want to make a design improvement. Then you can obtain new design results with a few clicks by means of a robust, repeatable pipelined workflow. So when importing a geometry into STAR-CCM Plus, it is good practice to make sure that the geometry is clean and suitable for intended simulation. The surface repair tool in Simcenter STAR-CCM Plus allows you to investigate whether the geometry is clean and allows you to repair it manually. In this case, our imported geometry of a large cruise vessel is full of errors, and you can imagine this takes a very long time to clean manually. Besides the option to repair the surface manually, Simcenter STAR-CCM Plus also has an automated approach called the surface wrapper. Here you can see a side-by-side comparison of the original geometry on the left and the automatically clean geometry on the right. Although both geometries look very much the same from the tessellations, we can clearly see that they are a bit different. Now, showing the surface deviation from the wrapped surface, it can be seen that most of the geometry is within 1 centimeter of the original geometry. Now, in order to make the simulation suitable for any wind direction, we created an operation to rotate the cruise vessel within our virtual wind tunnel. Here you can see a rotation of 90 degrees. Now, when rotating our cruise vessel, we also need to update our refinement areas to capture the wake in order to get accurate results. This is all done within the operations to automatically create boxes for the wake findings. Now, the final geometry operation is a subtract operation to subtract the cruise vessel geometry from the wind tunnel in order to get the fluid domain. So now the fluid domain is meshed. First, a high quality surface mesh is created. Next, the volume mesh is created. And in this case, we are using the so-called trim mesh. For accurate results, it's important to simulate sufficient length behind that cruise vessel. To extend the domain, the outlet surface is automatically extruded, and the mesh as well. Now, Simcenter STAR-CCM Plus allows you to create pipeline operations to automatically go from a dirty CAD model to a high quality mesh, significantly reducing your engineering hours. Now, from there, we can easily assess the mesh that we just created by creating a mesh scene to quickly monitor the mesh quality. Now, from this point, the appropriate physics models can be selected to best present the model and user requirements to drive certain client outcomes. Now, from there, the boundary conditions can be set to values to correlate to the scenario that is being considered. Now, here you can see the inlet boundary as well as the outlet boundary. And lastly, you can see the yacht that is agglomerated into one boundary. Now, with STAR, it's very, very easy to compile a bunch of scenes and reports with only the use of a few clicks to track key performance indicators. Now, these scenes, these monitoring scenes return case-specific qualitative and quantitative results. So you can see the force plots. And from there, we have our little pretty scenes with the streamlines showing both pressure on the yacht as well as the velocity contours. And then you can use fancy renderings and so on, like this volume rendering of turbulent kinetic energy. So Simcenter STAR-CCM Plus enables streamlining the simulation process from CAD import to final performance evaluation. By leveraging template-driven workflows, users can automate and standardize each design, reducing manual effort and accelerating the transition from design to solution. The automated process begins with a CAD import, followed by resistance analysis to assess total resistance versus speed. Now, predefined templates then enable seamless open water propeller evaluation, calculating thrust, torque, and efficiency. Finally, the workflow automates self-propulsion and speed prediction, integrating hull resistance analysis effortlessly. Now, this automation ensures fast, high-fidelity results with minimal setup, enhancing productivity and design optimization. I want to briefly demonstrate how easy it can be to generate bare hull resistance data with our CFD product, Simcenter STAR-CCM Plus. So STAR-CCM Plus has a completely automated workflow functionality, and it merely takes minutes to set up a high-fidelity CFD calculation on our virtual tow tank template or VTT, as shown here. So here you can see we can set the speed, and then by just only one click of the button, you can run all of your simulation operations. Now you'll see the mesh is being prepared. And after the mesh is prepared, you'll get real runtime results from your simulation. Here you can see our residuals are populating. And we have a similar template for generating open water propeller curves that can be used in a self-propulsion system. And we can generate the information needed to perform a self-propulsion analysis. So with STAR-CCM Plus, you are offered various levels of complexity to model propellers. Now, each catered towards a specific outcome, which differs in complexity and information that can be extracted from the approach. Now, the complexity fidelity hierarchy moves from a virtual disk models to moving reference frame to rigid body motions. And that data can be input into a self-propulsion analysis using our VTT. And we can quickly generate self-propulsion data that we need. We can compare our bare hull resistance to our self-propulsion resistance to determine thrust deductions and various wake fractions. And we can validate our CFD calculations against open water data with the largest deviation having only a 3% discrepancy. So with forced moving wave tank template, we can set up waves any way that we like. So using our custom tree, we have a sub-node for wave properties. We can input the wave direction, amplitude, and wavelength for our wave. Now, can we here we can easily see that simply changing an intuitive parameter, we can initialize the domain with the appropriate wave we defined. So we are changing the wave amplitude from flat water to waves to oblique waves with just a few clicks of the button. So it is really easy at that to change your wavefront setting. Just the 3 critical parameters are exposed to you, and all the best practices behind waves are being implemented in the background for you. So we can easily analyze the craft in different sea states, and here you can see the craft operating in head seas as well as oblique seas on the right. Now, we can see the difference in vessel response and especially the differences in roll motions. Now, previously, the run was set up as a fixed speed bed hull analysis. Now, we will include the propellers into the design. We simply have to check that these are now enabled. And then we need to make the motion a free motion, because instead of prescribing the speed, we want to see what the speed will be based on the thrust produced from the propeller. And we can easily swap out propellers as well. In this case, we can use company X or company Y's propeller and compare their performances. This is what you need to do in order to predict time to plane or top end speed or any type of self-propelled simulation. Now, I previously showed how the hull behaves at constant speed in head waves. Now we can see how it behaves under its own self-propulsion load. Now the vessel behaves a bit differently, and we can see how the surge speed is affected. In this situation, the forward speed is reduced by about 20% with each wave impact. Now, if we can update an entire simulation manually with a single click using pipeline operations, we can also easily automate this using our intelligent search and parametric CAD. Simcenter STAR-CCM Plus will then automatically find results for you faster. So to go further on this point, I want to configure my model and this launch a design exploration and associated campaign parameters, which includes the design, which is your geometry, the boundary conditions and mesh. Now this campaign is carried out via the design manager tool included directly into STAR-CCM Plus. I define the values of my parameters, the objectives and the constraints, and I obtain the results that I will interpret. So, Simcenter STAR-CCM Plus has this integrated design exploration tool, which allows to easily create a full 360-degree sweep of wind directions for this cruise vessel, which gives us an assessment of the aerodynamic loads. Now, all of the results are shown within the same user interface, and we can just browse through the results at our own leisure. Now, all visualizations are updated with our selection, giving us direct insights. Now, alternatively, we can interact with any plot and see the simulation results corresponding to any point on that force graph. Now, Simcenter STAR-CCM Plus enables efficient ship bulb optimization by focusing design modification solely on the bulb shape, making it ideal for retrofitting existing vessels. Through intelligent design space exploration, the solution helps minimize ship resistance, improving hydrodynamic performance without requiring a full vessel redesign. Now, this approach enhances efficiency, reduces fuel consumption and operational costs while ensuring a streamlined retrofit process. So in the next animation, we will see our design right in the middle there. Now on both sides, we can see the wave pattern of both loading conditions, fully loaded and empty ballast. And below each loading condition, we can see the history of total resistance. Now, since we want to optimize both loading conditions at the same time, we have an equally weighted multi-objective goal. So each dot is a different design. The red dots are designs that did not meet constraints for stability, motion, and freeboard. So some of the designs have failed due to CAD errors. You can see them at the bottom there. Now the intelligent search is learning from each design and applying that data towards the end of the design exploration to ensure that there is much less failed designs. Now the solid line connects the best designs. So we end up with better designs, but also the insights to why this specific design is better. So Simcenter STAR-CCM Plus has a wide range of physical models. For virtual wind tunnel simulation, one might choose the RANS, the Raynaud Average Navier-Stokes method, to quickly get wind coefficients. But for certain applications, a more higher fidelity model is required. Now with Simcenter STAR-CCM Plus, you can easily increase fidelity by going to a DES simulation. Now DES simulation is detached eddy simulations. So a reason to use DES might be the fact that you are interested in passenger comfort or safe helicopter landings. Now, for these applications, it's beneficial to have more insights in the unsteady flow close to the deck surface. Now, Simcenter STAR-CCM Plus covers a wide range of applications, including propeller performance, propeller hull interaction, crash stop and bollard pull, and many more. Now, hydrodynamic performance engineering is critical to the design of any vessel. Over the last 5 to 10 years of computational fluid dynamics has played an ever-increasing role in vessel design. CFD has extended beyond external hydrodynamics to include more complex motions and physical processes, allowing the shift towards simulating full-scale vessels under real operating conditions. So in summary, Simcenter STAR-CCM Plus offers faster standard simulation workflow by cutting simulation time from weeks to hours with automatic surface cleaning while delivering rapid full-scale product performance insights. Now, STAR also offers smarter and automated simulations. So by using our templates for quick full sweeps or intelligent searches to drive the innovation in your company. And the software also offers an efficient design space exploration by simplifying model setup and pre-processing for faster results. And then finally, it provides higher fidelity and broader application by enhancing accuracy by shifting from, let's say, RANS to DES for better dynamic load predictions and passenger comfort, and expanding on usability with multi-phase simulation capabilities. And now I would, oh shucks. And now I would just like to hand over to my colleague Christian de Wet, who will share Simcenter Amesim's dynamic ship propulsion system analysis. Thank you so much.
Thanks, Jan, for that. So yeah, next up, I'm going to talk about Simcenter Amesim, which is the 1D system simulation software from Siemens. So as you would know, that a ship is a system of systems with various components. Now, Amesim enables us to build a 1D system of these and see how they interact with each other. There's over 6,500 multi-physics models included in the software, where it goes from hydraulic, pneumatic, thermal, electrical, and mechanical. Where like mechanical, you have like an engine or valve or pipes that you can click and drag and drop into the window, and that's how you can basically build it out. You you can check in various performance metrics to check what how the system responds with, like, for example, fuel consumption or the power requirements. You can then, because the software runs in real time, what it enables you to do is also develop the software for a PLC coding, and then you can test and virtually commission your PLCs through the software because the software runs in real time. As you can see later on, we'll do is we'll then couple the 1D system simulation with 3D CFD and a ghost simulation. Some later slides on that. So you can see just how the ship is built out. You can see the icon of the ship on the left, and on the right hand side you have your weather conditions like for the wind and then the ocean. And then you can build it around it. So you can see we have like 2 propellers, and with these 2 propellers, it's connected to 2 electric motors, and then electrical circuit connecting all of them together, where you have your main electric generators and auxiliary engines. So this is essentially a hybrid system that we've developed here. Then each component can be expanded to go into the system of a system, and then you can make various changes. So you can see, for example, for the engine, you can make like the bore and the stroke changes to it and see how it affects it. And then there is more than 48 libraries included in the software that you can just actively use. You can see 2 images of like um, routes that can be applied to your Amesim model to see how the fuel consumption of the vessel will change throughout when it's journeying across these various sea routes. Here's some typical examples that you can get out. So you can see the fuel consumption used and also the CO2 emissions with like plots and bar charts. And here on the top right hand side, you can see you can get the accumulative data over a few days as the vessel journeys across these routes. And with the International Maritime Organization having various guidelines and requirements for seagoing vessels for, say, adverse weather conditions and also for calm seas with different speeds that they need to run at, so 4 knots and then 14 knots. So you can use Simcenter Amesim to build these 1D systems and assess the performance of, say, the propulsion system. So if you take a look at that, what we would like to require is the size of the propulsion system and also at these various speeds, and then also different type of hull resistances. So, for example, a statistical hull resistance, and then both for calm water conditions and adverse weather conditions. You can see this is how the software looks like. So for now, we're going to just start off with a much simpler model of the boat. So first, what we're going to do is we're going to go and set the power requirements for the calm seas and use a statistical Barras method for the hull resistance. Now we can go and set the speed to 14 knots. So you can see we can set to 14 knots, and then you can run the simulation and see, okay, right, we need 4.5 megawatts that's needed for that. Now we can look at adverse weather conditions, so changing the weather conditions to the Beaufort 4.7, and then rerun the simulation and see what the power requirements would then be. You can see, you can check the results, and then from there you can see it's going to roughly require about 1 megawatt at 4 knots. For this specific man engine, you can see the performance curve of what's predicted in blue, and then what's required or what the max power can give. So you can see the engine that is specified will meet the criteria. So it's making these right decisions early on in the design process at the very start of the project. And we can carry on to looking at not using these hull resistance models, but having CFD results that you can import into your Amesim model. Both for hull resistance and for propeller. So you can see now if we can expand it to the propulsion system, you can go and select the propulsion system, and you can see the diameter and the blade area ratio. Then we can look at the performance maps for this propulsion system, look at fuel consumption, CO2 emissions, the propeller efficiency. And now we can do a comparison between the built-in statistical resistance models compared to the CFD results. So you can see we're importing the CFD results. You can see the table. We can now go and set the units in this table. So this is now previously we got the CFD results out for for various speeds, what the resistance, the drag force is of the hull, and then you can see after saving it, we're going to then do a few batch runs, and after these batch runs has been completed, set it, and then we can get to the results. So after a few batch runs have been completed, you can check what the results are with you can see the two results tables that we can then compare with each other. And then the two lines that will become available is the yellow is the reference that we would like. The yellow and then the blue is the CFD results, and the red is the statistical approach that's been followed. You can see the CFD results do match it a lot closer. So yeah, combining that quicker simulations with the CFD results to gain a better accurate model prediction. Then lastly, what we can do is we can couple Simcenter Amesim with your Simcenter STAR-CCM Plus, what we refer to as a functional mock-up unit or interface. This high fidelity methods can be used to take your propellers and your, so for example, your hull resistance curves and dynamically connect it to STAR-CCM Plus. So you have a bidirectional connectivity between your 1D simulation, your 3D simulation. And this is useful to do like transient simulations where you have in situ configurations where the boat will go over waves, and as it travels there, you can dynamically see how your system would respond. And then look at what the performance metrics would be, like the power requirements for the propulsion system, and also what the fuel usage would be. So in summary, it's making the right decisions early in the CFD results in the process, with using CFD results either being imported into your model or that you can couple directly to STAR-CCM Plus. So with that, we can take a look at some key takeaways that we would like to give you within in this webinar. A lot has been covered today, so the key takeaways are is that with Siemens Simcenter, you get a holistic digital twin by coupling both 3D CFD simulations and then 1D system simulations. This can then be used to generate accurate and detailed performance maps. You can make quick design changes. Having this digital twin that's high fidelity, you can make quick design changes, seeing what the different sort of components or various different design changes can have on a performance. This then requires fewer prototyping that's required and less physical testing, which gives you a faster time to market. It helps you to also look at the fuel consumption that your vessel will have, and also see what it would be in the performance would be in any sort of sea conditions. You can then also go ahead and look at optimization studies, looking at various design envelope of the vessel to try and improve and also meet the guidelines that's been set. So with that being said, we have a marine shop planned in Cape Town in May, on the 21st of May. This will be free of charge and it will be hands-on, and that's where you can test out STAR-CCM Plus for yourself. And with both my colleagues at Siemens and also my colleagues at Aerotherm will assist you on this day to test out how the software performs. There are limited seats available, so all the attendees to this webinar will receive a link afterwards to register for this event. And Ignas will put up a poll, and if he shares the poll, you'll be able to choose if you would be interested in attending this workshop. With that being said, I'd like to thank you for today for attending this webinar.